Hello guys, I welcome you all to my channel Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this one another problem from Fundamental of Physics by Resnick Halliday, and this is from chapter 2. So the problem says that from t equals to 0, t equals to 5 minutes, a man stands still, and from t equals to 5 minutes until t equals to 10 minutes, he walks briskly in a straight line at a constant speed of 2.20 meter per second. So let me write that from t greater than equal to 5 minutes and less than equal to 10 minutes, the velocity is 2.20 meter per second, and before 5 minutes, let me write that for t greater than equal to 0 and less than equal to 5 minutes, the velocity is 0, since the man stands still. From t equals to 0 until t equals to 5 meters, a man stands still. So the velocity is 0, and then from this the velocity is 2.20 meter per second. Now next it is said that what are his average velocity and his average acceleration in the time interval between 2 minutes to 8 minutes. So let me write that for A and B. For part A and B, the time interval is, let me write that the time interval is greater than 2 minutes and less than equal to 8 minutes. For this interval we have to find the average velocity and the average acceleration. So this will be the answer for part A and B. And then for time interval 3 to 9 minutes, again we have to find the average velocity and average acceleration. And in part E it is said that sketch the position x versus t and v versus t and indicate how the answers A through D can be obtained from the graphs. So now, while reading the statements, we can say that from t equals to 0 until t equals to 5 minutes, the velocity is 0. So this means that if this is v versus t, if on the y-axis we have v in meter per second and this is t in minutes, so we can plot this, right? And let's say if I'm going to consider the velocity in meter per minute, since the time intervals are given in minutes. So first of all, I'm going to convert this velocity into meter per minute, right? So this is given in meter per second, so we need to convert this second into minutes, right? So we need to convert the unit. So let me write that this is meter per second. So we need to cancel out this second, and we can write that 1 minute is equal to 60 seconds. So second will cancel out, so we will have 2.20 into 60. This gives us 132 meters per minute. So now let me erase this, and I am going to plot this v versus t in meter per minute. So let's say that somewhere here is 132. See, this is 132. So now in the problem statement, from 0 to 5 minutes the man stands still, so his velocity is equal to 0 for this interval. So let me plot this. So from 0 to 5 the velocity is 0, and then from 5 to 10 minutes the velocity is 132. So, and the velocity remains constant, right? So the velocity remains constant from 5 to 10 minutes, like this. So then we will have a rise until 10 minutes, like this. We will have the graph like this. So this is v versus t, and then for x versus t we have to find the distance traveled from 0 to 5 minutes and then from 5 to 10 minutes. So now we know that velocity is delta x divided by delta t. So now the velocity for 5 to 10 minutes, the velocity for 5 to 10 minutes is 132 meters per minute. So this means that this is equal to 132 meter per minute, and this delta x will be from 5 to 10 minutes, since he walks from t equals to 5 until t equals to 10 minutes. So this delta t will be from 5 to 10 minutes, right? So we can say that delta x from 5 to 10 minutes, this is equal to 132 meter per minute multiplied by delta t, and this delta t will be the difference of 10 and 5, so 10 minus 5, right? So this is, we can say that this delta t is 10 minus 5, and this is in minutes. So this minute will cancel out, and we will be left with the answer in meters. So now 132 multiplied by 10 minus 5 is 5, so this is 660 meters. So the change in position of the main from 5 to 10 minutes is 660 meters. So in other words, we can say that from t equals to 5 minutes until t equals to 10 minutes, the main walks a distance of 660 meters. And from 0 to 5, if we apply the same equation for this interval, so then we can write that v is equal to delta x divided by delta t, and delta x for 0 to 5 minutes, this will be equal to v times delta t, but velocity is 0. So if the velocity is 0, the distance traveled is 0. So he stands still, so he covers 0 distance. So now we can plot this data as well. So from 0 to 5, no distance traveled, and then since from 5 to 10 the velocity is constant, right? So if the velocity is constant, the distance traveled is 660 meters, right? So if this is 200, 400, 600, so 660 is somewhere here. So at t equals to 10, 660 is somewhere here, this is some point, right? Let's find the answers from A to D, and then we will plot the remaining x versus t. Since we need some data, we need to find the position of the particle at t equals to 6, 7, 8, 9, so in order to have that plot, right? So first of all, the solution of A and B. So this will be our solution for A and B. So average velocity, V average velocity from 2 to 8 minutes will be x8 minus x2. This means that the position at t equals to 8 minutes and the position of the main at t equals to 2 minutes. So x8 minus x2 divided by delta t. So we need to have the position of the main at x equals to 8 minutes. At t equals to 8 minutes. So again we can use this same velocity equation, but we can write that v at, if we know the instantaneous velocity, so v at 8 minute is equal to the position at 8 minute divided by delta t. So now from this we can say that x8 will be equal to v8 into delta t, and this delta t is that time interval from which he is moving, right? And we are considering from 2 to 8 minutes. So this will be the average velocity from 2 to 8 minutes, but until 5 minutes he remains still. So here we are going to use the 8 minus 5 time intervals, since from 5 minutes he is moving, right? So x8 will be equal to v8, so the velocity at 8 minutes. So from 5 to 10 minutes the velocity remains constant, that is 132. So this means that v8 is 132 and delta t will be 8 minus 5. So from 5 minutes he starts moving, right? So this delta t will be 8 minus 5. So this is 132 into 3. So again this is 132 meter per minute, and 8 minus 5 is 3 minute. Minute will cancel out, we will have the answer in meters. So this is 132 multiplied by 3. So this is 396. So x8 is 396 meter. So this means that the position of the main at t equals to 8 minutes is 396 meters. So this means that if on the graph, if this is t equals to 8 minutes, so we have this point, this particular point at 396, and here the delta x from 5 to 10 is 660 meters. So this means that the final position of the main is 660 meters. So if this is 600, so 660 is somewhere here. So let me this is that particular point, and now at t equals to 8 minutes we have 396. So this is 400, so 396 is somewhere here. Let's see. So this is 396. This is somewhere here is 396, and somewhere here is 660. So this will be, now we can find the average velocity since we know x8 is 396 minus x2. So now again we can use the same equation, or we can use the same equation. Let me write that. For any x we have velocity times delta t. So now we can find x2. So x2 will be equal to v2 times delta t. So v2 is the velocity at t equals to 2 minutes. So the velocity at t equals to 2 minutes is 0, right? So this means that this is 0. So 0 into delta t, this is equal to 0. So x2 is 0. So this means that at t equals to 2 minutes, he is still standing there, right? So there is no distance traveled at t equals to 2 minutes, right? So x2 is 0. So here we need to put 0. This is 396 minus 0 divided by delta t. So now delta t is the whole interval. This is from 8 minus 2. This interval, while using this formula, this interval will be the interval from his from the point where he starts his motion, right? So for t equals to 5 minutes, right? And this is the, when we are finding the average velocity between 2 to 8 minutes, so here in this average velocity formula we have to use this delta t as the whole interval. So this is 8 minus 2. So 8 minus 2 is 6. But as we know that this 396, this is in meters and this is in minutes, right? So 396 divided by 6, this gives us 66. So this average velocity will be 66 and its units will be meter per minute, remember. So if we were asked to find the average velocity in meter per second, then we were required to change this into meter per second. But here in the problem statement we are not required to have the answer in meter per second. If you people are interested to find this average velocity in meter per second, so we need to convert the units. So now we want to cancel out the minutes. So 1 minute is equal to 60 seconds. Minute will cancel out. So 66 divided by 60. So that is 66 divided by 60. This gives us 1.1. So average velocity is 1.10 meter per second for this particular interval. Now in part B we were asked to find the average acceleration for this particular interval. So now the A average will be the velocity at 8 minutes, minus the velocity at 2 minutes divided by the total time interval. So now we know that V8 is the velocity from 5 to 10 minutes is constant, which is 132. So 132, V8 is 132, V2 is 0, since from 0 to 5 minutes he stands still. So 132 minus 0 divided by delta t is 8 minus 2. So this is 132 divided by 6. This gives me 22. And this will be meter per minute square. Since this is the acceleration, this 132 is meter per minute, and this is in minutes. So meter per minute square, the the average acceleration for this particular interval. Now if you are interested to find this average acceleration in meter per second square, so we have to convert the units. Now this will be multiplied by, now we want to cancel out this minute square, so 1 minute is 60 seconds, so we have to take square, so this will become square. So now 22 divided by 60 square, so this gives us the average acceleration for that particular interval equals to 0.00611. So this is in meter per second square. Now in meter per minute square, the average acceleration is 22 meter per minute square, and in meter per second square it is 0.00611. Now for part C and D, it is said that again find the average velocity and average acceleration for time interval 3 minutes to 9 minutes. So now for t greater than equal to 3 and less than equal to 9 minutes, this is the solution of part A, and this is B. Then C. So C is again average velocity. So average velocity will be again x9, the position at 9 minutes, minus the position at 3 minutes, divided by total time interval, that is delta t. Now again using this same equation, we need to find the position of the main at t equals to 9 minutes. So x9 is equal to v9 into delta t. And let's say that this is delta t dash, since this delta t is different from this delta t. This delta t dash is always this delta t dash always represent that interval from which the main starts his motion. So this is delta t dash, right? So I will put dash here as well. This is delta t dash. So now the velocity at 9 minutes is again constant. This is the velocity at 9 minutes is constant, which is 132. So v9 is 132 time delta t dash. So delta t dash is 9 minus 5, since at 5 he starts moving. So 132 into 9 minus 5 is 4. This is 528. 528 meters. Again, this is in meter per minute, this is in minutes. So meter per minute, minute will cancel out, we will have the answer in meters. So this is 528. So now at t equals to 9 minutes, it is 528. So 500 is somewhere here, so 528 will be somewhere here. So let's locate that point. Let's say that this is that point. So now if the velocity is constant, we can join all these points, right? Let me join this point and the last point, right? They will lie on one straight line since the velocity is constant. So equal distance is covered in equal interval of time. So this means that this will be straight line. When the velocity is constant, the x versus t will always be straight line like this. So this is x versus t plot, which is required in part E. Now we can find the average velocity. We know x9, we know x3 is 0, since from 0 to 5 the velocity is 0. So if the velocity is 0, using this equation we will get x3 equals to 0. So this is 528 minus 0 divided by delta t. Now this delta t is 9 minus 3, this is 6. So 528 divided by 6, this gives me 88. So average velocity is 88 meter per minute. V average is 88 meter per minute. If you want to convert it into meter per second, so 1 minute is 60 seconds, minute will cancel out. This is 88, this is minute. So 88 divided by 60, this gives me 1.467 meter per second. And now in part D, the average acceleration, this will be v9 minus v3 divided by delta t. Now v9 is from 5 to 10 minutes, the velocity is constant, so the velocity at 9 minutes is also 132. This is 132. So this is 132 minus v3. So again, from 0 to 5 minutes, the velocity is 0 since he stands still. So this is 0 divided by delta t. Delta t is this time interval, 9 minus 3, which is 6. This is 132 divided by 6. This is 22 meter per minute square. And again, if we convert this meter per minute square into meter per second square, so we will get that same answer, since this is 22 meter per minute square and this is 22 meter per minute square. Now in part E, it is said that sketch x versus t and v versus t, which we have already done. And it is said that indicate how the answers through A to D can be obtained from the graph. So now for part A, which is the average velocity from 2 to 8 minutes, we can always find the average velocity using the graph from for x versus t. So how to find it? So for that we have to find out the point at, we have to locate the point at x at t equals to 2. So x at t equals to 2 is this particular point. Let me mark it. And then x at t equals to 8 minutes. So this is 8. So we have this particular point. Now we need to join both of these points to find the average velocity. So let me join both of these points by a straight line. So the slope of this line will give us the average velocity for part A. Let me write that this is for part A. So how to find the slope? Again, for part A, using the graph, this will be V average, and the slope of this line will be the rise divided by the run. So now the rise is, this rise is 396, right? But if we do not know the exact value using the graph, so we can say that this is approximately 400. So 400 divided by this 8 minus this 2, so 6. So this is 400 divided by 6. This is rise divided by run. So 400 divided by 6, this gives us 66.67. And if we know the exact value, so we will get the exact average velocity, that is 66 meter per minute. So now we know the exact value that at t equals to 8 minutes, the x value is 396. So then the rise will be 396. This height will be 396. So 396, if we write, then this is 396 divided by 6. So this will give us 66 meter per minute, which is exactly the same as we have calculated here. This is 66 meter per minute. And similarly for part B, if you want to find the average acceleration, so again we have to, since in average acceleration we are going to use v versus t, right? Since the average acceleration uses the velocity values, right? So we have to use the v versus t. Now the velocity, we have to locate the point for the velocity at t equals to 8 minutes. So this is 8 minutes, so this is the velocity. So this is the point of interest. This is our point of interest. And at t equals to 2, this is the velocity. So again we have to join both of these points. So this will, the slope of this line will be the solution for part B. So now if we find the slope of this particular line, so this will be rise divided by run. So let me write that the solution of part B using the graph. Let me write it here. This is B. So average acceleration. So now the rise is 132, this height is 132 divided by the run. So this is 8 minus 2, this is 2. So 132 divided by 8 minus 2 is 6. So we will get that same answer, 132 divided by 6. This will give us 22 meter per minute square. And similarly for part C, since in part C again we are asked to find the average velocity between t equals to 3 until t equals to 9 minutes. So now the x at 9 minutes is this particular value at this particular point, and 3 minutes is somewhere here. So we need to join this point and this point. So now if I join this particular point with this particular point, so this is 3 minutes and this is 9 minutes. So now if we find the slope of this green straight line, so now the slope of this green straight line will be the rise divided by the run. Now we know that at t equals to 9 the x value is 528. We have determined this value, this is 528. So on the graph we can say that this particular point is 528, this is 528. So now for part C, the rise, this is the rise, so the rise is 528 minus 0. So this is V average 528 minus 0 divided by the run. So now this is the run, so 9 minus 3, so this is 6. So we will get that same answer. This is 528 divided by 6, this gives us 88. So for C, this is 88 meter per minute, and from the graph we get 88 meter per minute. And similarly for part D, at t equals to 9, this is the velocity value, this is our point of interest, and at t equals to 3 this is the velocity value. So we need to join this point and this point. So now let me join these 2 points. So this is 3 minutes and this is 9 minutes. Now if we look into this straight line and this straight line, they are parallel to each other, so the slope of both of these lines will remain the same, so they will give us that same average acceleration. So let me find this average acceleration. I am writing here, right? So this is the for part D, using the graph, the average acceleration will be equal to the rise divided by this run. So rise, now this rise is 132 minus 0, so 132 minus 0, right? So this is 132 minus 0 divided by the run. So this is the run from 3 to 9, so 9 minus 3, so this is 6. So we get that same 132 divided by 6, which will give us 22 meter per minute. So this is 22 meter per minute square. So this is how we can find the average velocity and acceleration using the x versus t and v versus t. And using the formula we can always use this formula to find the average acceleration and the average velocity and the average acceleration using these 2 formula. And the position of the particle at any interval can be determined using this formula. So this is the solution of this particular problem. I hope it will help you in your learning. Do subscribe Engineers Academy if it helps in your learning.